So this is immediately so interesting for me because number one, we know from Archimedes' principle that there's going to be some sort of buoyancy force when you have that much weight, 300 kilograms or 200 kilograms in the water. But as you're coming up, there's also drag of the water. So now I'm just thinking, okay, breathing aside, to me, breathing part, that's the most impressive thing. I also love how the judges has to like sort of waddle around to make sure they get around to the spot. So from Archimedes' principle, we know that the amount of buoyancy force is equal to that of the volume of water that this thing displaces. So all we needed to find out was basically how much volume the barbell takes. And if we assume a uniform density of that of the iron, we know it's 300 kg, then we can calculate here's how much volume, right, the barbell takes up. And then we just have to convert it to water's density to allow us to figure out how much buoyancy force that is. If we take the density of water as 1,000 kilograms per meter cubed, and we know that here's how much volume we have meter cubed, so 1,000, then basically 38 kilograms is basically how much force we're getting. So strictly speaking, from the buoyancy forces perspective, this is really 300 minus 38. So it's around 262 kilograms of absolute weight that this guy's carrying. But what about the drag force on the concentric? So here we know the equation of drag on the barbell is going to depend on the density of the water, the velocity of the barbell, and then this drag coefficient that's dependent on the shape as well as the nature of the flow. In our case, we know it's the laminar flow because it's moving quite slowly, as well as the cross-sectional area. So we know the density of water already. We're assuming it's probably 0.4 meters per second if it's like a max out effort, just based on Will Ratelle suggestions. From this, we can figure out that the drag coefficient for the cylinder in laminar flow is 1.2. And now we should have all we need to calculate the drag as long as we assume, where's the equation? As long as we assume the areas of those barbells and we just simplify. So after doing the calculations, it turns out the drag was only like 1.5 kilos extra. So really, the big boost is from buoyancy force. And then this is still impressive as heck. Like 262 kilograms on land is insane enough already. Imagine trying to do that in water. So 300, hats off. This is amazing.